Okay, now let's solve the very last question of the day, which is question number 6, which goes up until question number 9. So this is a step-up autotransformer. So let me just draw the image of a step-up autotransformer. So it looks something it looks something like this. The the output is now on this side, right? So this is now my output and this is my input. So okay, we're back to solve the next problem. The Okay, I was having some technical issues here. Okay, so this is what step up auto transformer is going to look like. So you have 110 volts here, and now the currents in different color. So primary current is 150, and this current is what we call the I low, and this V is what we call the V low. And then we have this side, this is what we call the V high, and then we have this current, that's what we call the I high, which in this case is equal to this current here, which is ISE. This winding is what we call NSE, and this winding is what we call NC, and the voltages are just the same. So this is VC and this is VSE for the voltages. Okay, so now they want us to find the primary voltage rating of the two windings. So let's see what this looks like as a two winding. So we have the primary side and we have the secondary side. And here they have told us that the secondary side of the two winding transformer is 110. So that means that this VC is actually 110. So this is my VC. So VSE is now what we are looking for, VSE. So how do we find VSE? So the step is to find uh, the current I high. So the current I high, we get it from this equation. So S input output is equal to V low I low is equal to V high I high. So this is how we find the apparent power of the autotransformer. Now we know the SIO, which is 16.5 kVA, and we know what else do we know? And we know I high is given to us as 50 amps. So this I high is 50 amps, right? Because this is 50 amps of the auto transformer, right? So now we can find V high as SIO divided by I high. And if I do this mathematics, SIO, which is 16.5, divided by I high, which is 50, will give me V high. So V high is 16.5 divided by 50, and then remember this is kVA, so I'll multiply that by 1,000 to get the voltage. So I'm getting the voltage is 330. So V high is 330 volts. So the voltage here is 330 volts. So what does that mean? That means that VSE is nothing but 330 minus 110, and this is 220 volts. And this is the primary side, which is of the two winding. So VSA is equal to VP of the two winding, right? So it's VP of the two winding. So it is 220 volts. The next question is to determine the primary current, this current here, which we call ISE, and this current here is IC. So what is going to be the primary current of the two winding? So as we can see, if VSE is equal to 220, the current in series, which is ISE, we can see it from here, which is equal to I high is 50 amps. So I primary side, which is equal to ISE, which is equal to I high, is 50 amps. We can see it from this diagram. And as you can see, that's the value that we also have here. So 50 amps. Now determine the secondary current of the two winding. So in that case, it's IC. So how do we find IC? One thing we have to recall is that if we have a step-up transformer, the voltage is increasing. So we are moving from 110 volts to 330. But in terms of the current, is the opposite. So if our I low is 150 and our I high is 50, which decreased, so what is going to be the direction of the I common? So the common winding will have a downward direction. So I common is going to be downward in order to get an output or the secondary voltage as 50. So this needs to be downward, and then IC will become what? 150 minus 50, which will give me 100 amps. Okay, that's the value we have here. And if you don't believe, just take a KCL here. We can see from the KCL that I low is going in is equal to the ones that are going out, which is IC plus ISE. So this implies that IC is equal to IL minus ISE, which is equal to I low, which we have seen I low is 150 and ISE is 50. Then the overall current is 100. Then we have to determine the power rating of in kVA of the two winding. So the power rating of the two winding is SW. So how do we find SW? SW is nothing but VC times IC. So this is a way to find SW. SW is equal to VC times IC, and we have seen this before. VC is 110, and IC we found it as 100, right? So IC we found it as 100. If we do this calculation, 110 times 100 is 11,000 volt ampere, which can be written as 11 kVA. So this is how we solve autotransformer problem. Thank you for your time. See you next time.